Hello, I'm Efstratios Papoutsis from ICCS. I'm going to present the paper Innovative Flexibility Management Framework for Distribution Energy Resources Participants in Local Markets. It's a paper developed under the framework of Efstratios project, which is an EU-funded Horizon 2020 project. We'll begin with the rationale and motivation behind this paper. First of all, there is a need to meet the targets set by the European Union for climate neutrality by 2050 and greenhouse gas emission reduction. Apart from the climate challenges, there is also current energy challenges that should be met, like the MEDPOWER, which is a plan of the European Union to rapidly reduce dependence on Russian fossil fuels and fast forward the green transition. The demand-side flexibility management appears to be a principal mechanism to tackle the current energy challenges that I mentioned before. Efstratios project, which is an EU-funded Horizon 20 project which started at October of 2019, introduces state-of-the-art flexibility management framework for demand-side aggregators, aiming also to bring together a value flexibility with market mechanism, incentivizing also flexibility. In this slide, an overview of Efstratios project is presented. 4 complementary products are developed under Efstratios project in order to serve the needs of all energy stakeholders, from grid operators to consumers and aggregators. The products that developed are the 4 products that developed are Seriflex, which is a tool for flexibility manager; Gridflex, which is a tool for grid operators; Marketflex, which is a tool for market operators; and the Efstratios platform, which is the middleware of the project. The general concept of the project is presented in this figure. Seriflex, which is a tool for flexibility manager, receives inputs from the operational inputs from the flexibility assets and distributed energy resources. It processes this data in order to produce operational schedules and the profiles of these flexibility elements. These operational schedules are sent through Efstratios platform to Marketflex, a tool. On the other side, the Gridflex receives data from the grid, and it processes them in order to forecast the state of the grid, and uses this input in order to produce flexibility requests. These flexibility requests are sent through Efstratios platform to Marketflex tool. Then Marketflex tool checks the operational schedules against the flexibility requests that sent from Gridflex, and accepts or rejects them. And the accepted and rejected operational schedules are sent to the Seriflex tool through Efstratios platform, which then is responsible to send activate signals to the corresponding flexibility assets and activate them. The Efstratios solution will be tested in real conditions in 4 pilot sites in 3 EU member states, namely Bulgaria, Slovenia, and Greece. Some more details about Seriflex tools are presented in this line, since this paper focuses mainly on the functionality of Seriflex tool. It consists of 4 layers. The first one is the integration and data management layer, which is responsible to integrate the different physical assets. It's responsible for the data retrieval and further storage of the data. The flexibility application layer, which is responsible for the analysis of raw data and further the modeling and forecasting of the flexibility assets. The flexibility aggregation and cluster layer, which is responsible to aggregate the available flexibility from the different flexible sources. And finally, the flexibility management optimization layer, which is responsible to optimize the utilization of the different flexible sources, taking into account different business and operational requirements. The functionality of Seriflex tool was tested in the present paper, was tested in a microgrid that's available in the Greek pilot site, and specifically in Xanthi, which is in the northern Greece. The layout of the microgrid is presented in this figure. It is it's constructed based on a DC bus architecture. It consists of a PV system and several flexibility elements such as a battery system, a power-to-gas system consisting of an electrolyzer, a fuel cell, and a hydrogel storage tank, and some flexible loads. In the context of Efstratios project, an SMA Sunny Island inverter was installed in the microgrid to serve as an interface of the microgrid with the electricity network. The flexibility elements mentioned before was modeled in order to be able to forecast the PV production and to forecast also the profiles of the flexibility elements. Since there was not availability of historical data from the side of the microgrid, physical models were used instead of data-driven approaches, and specifically for the PV system, a single diode model was used. For the battery system, which is a lead-acid battery, the kinetic battery model was used, and for the electrolyzer and the fuel cell, empirical models were performed. Some pictures from the microgrid are presented in this slide, the PV system, the battery system with the inverter, and the electrolyzer and the fuel cell. The operation of the microgrid was simulated for 3 consecutive days, and the results for the battery system are presented in this slide, which is we can see the baseline scenario and some lower and upper bounds that indicate the upper and the upward the potential upward and downward flexibility that the battery system can offer. These results can be used from the Seriflex in order to calculate the flexibility offers that should provide to the MarketFlex tool. Similar diagrams are also extracted for the other flexibility elements of the microgrid, such as the power-to-gas system and the flexible loads. The flexibility offer scenarios that the microgrid can offer to the local market through the Seriflex tool are presented in this slide, two indicative scenarios. The first scenario is about the provision of upward flexibility, which means the increase in generation and decrease in consumption. And the second scenario concerns the provision of downward flexibility, which means the decrease in generation and increase in consumption. For the first scenario, which is about the provision of upward flexibility, the battery system and the power-to-gas system was considered fully charged before to start the scenario. And for the second case, both systems, both the battery system and the power-to-gas system, was considered fully discharged. Now, in the first step, the provision of upward flexibility for each flexible element is presented for 1 hour with 15-minute granularity. In order to calculate the total amount of potential flexibility that the microgrid can offer, we should sum the upward flexibilities of each element. And the same is also true for the provision of downward flexibility, which is it's separated for each represented for each element. Here you can see a screenshot from the user interface of Seriflex tool. Here the user or the aggregator can filter and group the flexibility assets that are interested in order to make specific flexibility scenarios. Okay. And here we can see another screenshot from the Seriflex tool, where we have selected the flexibility elements that from the microgrid that we presented, namely the flexibility load, the power-to-gas system, and the battery system, in order to create a specific scenario. And are the conclusions of the presentation. A flexibility management framework aiming to assist the optimal coordination of local flexible resources and facilitate their participation in local energy markets proposed. The framework is deployed for this paper in the microgrid setup in Xanthi, Greece, where flexibility is originated by controlled use of the battery system and the power to gas system. And this resulting flexibility could be used by the local DSO to withstand congestion issues or imbalances. I think that's all. Thank you for your attention.
Please, any question? Yes.
In the end, your platform, who should be operating this platform? Because you have like the market and the operator and the grid.
The grid operator, each tool it's appropriate for other stakeholders. For meaning the Seriflex, it would be more appropriate to be used for an aggregator, let's say. For the grid flex tool, mainly from grid operators, and the market is for some market operator or something like this. The whole the Efstratios platform can be used from all, which is the middleware or the process can be used from all of them in order to group together all these solutions, all these tools.
Okay then, thank you so much. We conclude the second.